Hello, welcome. We're giving a minute for people that are getting in, and we'll start very shortly. Okay, I think so. Welcome to this Marine Biodiversity Networking Friday seminar. This is a seminar for a series that where we're going to present the GOOS BioEco EOVs. We had the first one already where we heard about what is this BioEco panel from GOOS and what were the EOVs. And today we're going to hear about two of these EOVs, the seagrass EOV and the macroalgae EOV. So this series is organized by Air Center with the collaboration of the MBON, that is the Marine Biodiversity Observation Network from GeoBON, and with GOOS. And GOOS is actually presenting some of the EOVs in alternate schedules, so they can also be at the right time for other parts of the world. But you can see all of them. All of them are recorded, and we will have them in the on our website in the West Air Center, also in the GOOS website for all of you that cannot attend live but would like to hear about these EOVs. So this is also a collaboration with the BioEco Ocean, and we have today the coordinator of this project. This is a EU project that really tries to work on these EOVs that we are going to talk today, and also in that we'll talk in other webinars from this series. Well, my name is Isabel Sousa Pinto. I am from the University of Porto and CIMAR, and I'm also co-chair of MBON, and I've been also participating in the discussion from the macroalgae observation. So I'll here just stop talking and we'll start introducing the speakers for today. So the first EOV that is going to be presented is the seagrass EOV. And for that, we have Lina Nordlund and Dimitris Poursanidis. Lina is from the Uppsala University in Greece, in Sweden, and Dimitris is from Greece, and they are the co-chairs of the working group that is working on the seagrass EOV. So please, you can start. Lina, I think it's you. Yeah.
Thank you so much. So I will share my screen here. And there. Let's see if I can. So, excellent. Okay, so hello everyone. As Isabel said, my name is Lina Nordlund, and I will talk about the essential ocean variable seagrass cover and composition. I will start talking, and then after a little while, I will pass over to Dimitris. So the GOOS, the Global Ocean Observing System, Essential Ocean Variables, are divided into three different groups: the physics and climate, the biology and ecosystems, the ones that we are focusing on in this webinar series, as well as the biogeochemistry. So the idea with the EOVs is to make it easier to measure and compare ocean data from all corners around the world. And the biology and ecosystems essential ocean variables are a set of minimum variables to measure to help identify and understand, as well as forecast marine life. So these essential ocean variables are providing a framework for coordinating ocean observations and ensuring globally comparable and combinable data. And today, or here now, we are going to focus on the seagrass. But just as Isabel said, that we have a whole webinar series. So if you want to have more details about the EOVs and hear more about the other essential ocean variables, you can follow this series. And I'm sure that Joanna will post a link to this in the chat. So the seagrass cover and composition, that's the name of this essential ocean variable. So why is this an essential ocean variable? It's been selected because it's feasible to observe. These observations can have a lot of impact, fairly or comparable low cost, and it's also possible to replicate this across the world. So when it comes to these essential ocean variables, it's really about being coordinated. And to be that, we sort of need to agree, or we need to come together and work together. And here's a little flow, starting with using a standardized protocol or standardized operating procedures, measuring the seagrass essential ocean variables. We will talk a little bit more about exactly what that means, and then publish this in a shared data system using FAIR principles, so this data becomes available and can be used and can be combined to produce really interesting products. And when we have more data and we can use this data, we will also advance our understanding of seagrass and the ocean. So being coordinated is not always so easy, but to our help, each of these essential ocean variables have a specification sheet. It's like a recipe of how to do it with guidance. So it provides a common framework that is sort of guiding the collection on what to do. And it helps to really standardize the way how we do it. And these specification sheets, they are targeting different audiences, and they have information on the background and justification of this essential ocean variable, different types of potential applications, which phenomena to observe, which observing specifications needed, and which approaches that can be used, and also a very important part about data management and information. Because regardless how much data we collect in the most amazing way, if we don't share that data, we are sort of a little bit missing the point. So this data management is a very important component. So these specification sheets, the seagrass cover and composition one, it looks like this, the cover of it. And throughout this past year, there has been a lot of activity to update these specification sheets across the biology and ecosystems, EOVs. And we have recently had an open feedback forum for people from around the world to be able to provide feedback. And with that said, developing the EOV is an ongoing process. So this doesn't mean that this is static, this is it. With new advances, things can be updated, etc. So in this specification sheet, you have information on the EOV subvariables, supporting variables, and derived products. So if I start talking a little bit about these subvariables, so this is actually really the key thing, the key measurements that are used to estimate the EOV. So this essential ocean variable, seagrass, is actually composed of these three variables: percent cover, species composition, and areal extent. We're going to talk a little bit more about each of those in the coming minutes. But first, I also want to mention the supporting variables. So these are other measurements that are useful to provide scale or context to the subvariable. So we have both environmental. So here are suggestions of variables that are often important and can provide a lot of context. So they are there to be picked from. But of course, it needs to be relevant for your local context. We also have the supporting variables that are EOV related. And here we have, for example, canopy height and shoot density. I think those are variables that many of us are already collecting. But there are some more suggestions. And we also have the phenomena to observe. Sort of, if we then come together and collect these subvariables, and sometimes with some more supporting variables, we can really contribute to the global understanding of habitat status and trends, estimated carbon stock and sequestration trends, as well as changes in species composition. So these are sort of the three major things that we aim on a global level to get better output for using these essential ocean variables. So now we're going a little bit more into depth with the seagrass subvariables, percent cover, species composition, and areal extent. And I will pass over now to Dimitris. So I'm just going to stop share and then he will share his slides. So thank you from me.
Here we are. So moving to some details on the three subvariables about the percent cover of seagrass, the species composition, and the areal extent, which are very important to understand the values. About the seagrass percent cover, we have defined three different resolutions: spatial, horizontal, spatial, vertical, and temporal. This variable is important because by having time series, we can understand the dynamics under the seasonal temporality, how it's going on in species that have a perennial presence, so to capture impact from various factors, and also to be precise on the plot level, how far we can go. In each of these subvariables, we have also some uncertainty measurements, also what's the sampling approach we have to follow with key reference that it's good to understand and read for applying more solid and with no issues. Species composition, to understand in the plot level or in the middle level, what's your composition of those seagrass species. Again, we keep the same resolution, different uncertainty measurements, and also the sampling approach and how we can follow that. The seagrass areal extent, here we can have different approaches. We have no tools from walking around the meadow when we have intertidal seagrasses, to using sensors from drones, to different satellite systems. We can see on the right figures what could be the impact of the selected sensor to the final areal extent of the seagrasses. Again, we provide here some suggestions about the ideal, the desirable, and the minimum in terms of resolution, in the uncertainty, and regarding the sampling approach, how to go and map our meadows. So by summarizing here for fixed points, we can see here how we can have approaches and technologies to be used to collect the COV to help observe priority phenomena. You can also have a fixed point with divers or other means for percent cover and species composition, and remote sensing tools for the areal extent. Again, we provide in the specification sheet the techniques, suggested methods, and also some supporting variables that have to be measured to explain findings. Again, for the continue of this approach, references and tables that support the collection of these subvariables to have a holistic view of your seagrass meadow. Okay, we collect the data, we have a nice data set, but what's the added value of that data set? The added value is to share your data. So as a bare minimum, you must ensure that the information that describe your EOV, the metadata of your data, become visible. And we have the ODIS, the ocean data and information system that you can upload your metadata, because maybe your data have to be published or are part of an ongoing research, but the metadata describe that we have data and we follow this approach. And yes, this can become public later, or you can contact us for sharing. And by that, this platform allow you to make aware of the community of the seagrass scientists that we have open data. Of course, then we can move to other portals that we will show later about how you can also upload your actual data, because if you share the data, then you create important tools in the toolbox of conservation science, since such open data contribute to a series of regulations and like the essential climate variables, the essential biodiversity variables. You have also the SDG of Paris Agreement 14, the QMI Montreal Climate, the UNCCC, the Ramsar, and other initiatives. So your open data could eventually support such contributions. And of course, on the OBIS, but OBIS is not only species occurrence, you can have various data set, and it is the world's largest open access repository for standardized marine biodiversity data, and it is interoperable with SBIF. So the data in OBIS can appear in SBIF, and OBIS is regulated by high-level UN system and is supported by a lot of countries. Using the GOOS BioEco metadata portal, this allows the data deposition, management, and long-term vision. And by that, you start to enter to the community of open data, allowing your data to become visible. And by having visibility, then your data become to be useful at various applications. You can look for this portal with this QR code or with a hyperlink, and to interact with the interactive map to see who is collecting data, where are the data, and what else in terms of metadata you can create and upload. Moving forward to new technologies that are coming that can support the seagrass EOV and the subvariables, the uncrewed vessels that you can deploy a vessel and let it go for hours or days or weeks, depending on the system, to map your seagrass meadows, to use AI-assisted EOVs for observations. You see a robot here that observes a reef, and you can take out the species composition. By that, you can use it in seagrass to take out the species composition at the plot level. eDNA and biodiversity using arms. It is an important technology that you can deploy in your seagrass meadows to collect data about biodiversity and also species composition. Moving forward for that, when you follow the EOV, you can clarify your question and hypothesis to decide how to allocate samples in space and time. It is a standard operation protocol that you can follow it, and your data become compatible across the globe. When you publish your data, you adopt the FAIR principles, which is very important for openness and for the open science. And you can take advantage of new technologies like the DNA or advanced imaging tools, and to enjoy that you increase the availability of Seagrass data and you become part of this important movement. We have to thank, and special thank, the community and the organizations that have support the Seagrass EOV development, the GOOS BioEco panel, and sharing GOOS vision. A big thanks to everybody that has provided feedback and support to develop this so far. And overall, a big thank to you that you listen to us and to be available for the next steps.
Okay, thank you very much, Lina and Dimitris. We are going now to hear about the macroalgae EOV. There was questions about this in the chat. We will have then a possibility of ask questions to the speakers after this second presentation. So please write your questions in the Q&A and they will be answered. Well, if not all of them during this session, then we can try to respond to them online. We'll send the response after. But anyway, so without any more, I would like to present Lisandro Benedicti from the University of Pisa and Jared Barnes from the US, that are the co-chairs of the macroalgae panel that is going to present the macroalgae EOV with a full name that they will tell you about. And similar presentation as the seagrass, but this time on the macroalgae EOV. Please, so is Lisandro, you're starting?
Yes.
Thank you.
So thank you, Isabel, and hi, everyone. Thank you for joining. I share my screen. I hope I get the right one. Okay, I hope you see. So the full name is macroalgae canopy cover and composition. This is one of the 4 habitat state variables, or EOVs, because it defines, is an habitat forming EOV, meaning that it provides also shelter for many other organisms. Just briefly to recap the principles that have inspired the identification and definition of EOVs. Basically, feasibility, impact, low-cost replicability. Here on the right panel, you have 4 quadrants, and ideally EOVs sit here where you have high feasibility, meaning that you can implement the EOV, you can take the relevant measurements with low cost, so the EOV can be implemented and the sample can be implemented easily with no necessary high-tech support. And impact, this is mostly related to social impact. This can be also quantified objectively in terms of the number of programs that have used DOV to assess progress towards national or international conservation targets. So these DOVs are identified on the basis of quantitative objective criteria. So macroalgae canopy cover and composition fulfill these requirements and is an important EOV because it supports many key or critical ecosystem services in coastal habitats. Supporting biodiversity, as I mentioned, is a habitat state variable, meaning that provides shelter and refuge for many other species, macroalgae, invertebrates, but even vertebrates and fish, for example. Supports blue economy. Aquaculture is an increasing asset for many countries. Climate regulation, sequestering CO2 together with seagrasses and phytoplankton. It provides nursery habitat. I mentioned fish, but also for other commercially important species, for example, crustacean and mollusks. Well-developed beds of macroalgae can also afford and contribute to protect coastline from erosion from intensifying storms, and also sites covered by flourishing macroalgae are important also for recreation activities, attracting tourists and divers. So it is important to implement sampling and monitoring programs that allow us to assess the status and trends of macroalgal canopy cover composition, and also to detect changes, and also to help identifying the causes of the drivers of these changes, which of course is a daunting task. Just a little bit background for how did we get to the EOV. We had many meetings within the BioEco panel of GOOS, but we also had key meetings that brought together experts from different areas worldwide. And notably, we had 2 POGO meetings in Tasmania and a working group at ANSYS in Santa Barbara. This work actually was focused on reviewing existing data sets, identifying existing data sets, basically who is doing what globally, reviewing monitoring methods, consolidate existing data according to FAIR principle. Standardization is a key word, as mentioned already in the previous presentation, because ideally the ultimate goal of all these efforts is to have a global integrated observing network of biodiversity. So interoperability and standardization are keywords. And of course, we found a lot of heterogeneity because people are doing things in different ways. In addition to looking at the literature, as part of a work that was published by Satterwhite and colleagues in Frontiers in Marine Science, we circulated a survey also to harvest more specific information about programs and their purposes. We had more than 370 respondents, identifying more than 200 active long-term, meaning lasting more than 5 years, observing programs focusing on marine biodiversity, not necessarily the macroalgal canopy cover EOV. These programs span about 7% of the ocean surface area, and were mostly concentrated in coastal region, the United States, Canada, Europe, and Australia. And then we zoomed into this data set once we put it together, and looking also at more specific programs that target macroalgal canopy cover and composition, and notably the kelp time database stand out as one of the most rich and long-term programs, including more than 450 sites all over the world monitored since the first half of the 20th century. Also zooming more into European programs, for example, we identified more than 40 monitoring programs for macroalgae in Europe run by 35 organizations, and most of these programs actually generated data that were made available on repositories, public repositories, mostly EOVs, and these programs actually generated data that helped individual countries to assess progress towards European conservation targets, so having an impact. As for the seagrass covering composition EOV, also the macroalgae have specification sheets where we have identified subvariables, which are essentially the key measurements we need to make and to take to generate quantitative data about the EOV, percentage canopy cover, stat density or stand density, canopy species diversity, aerial extent. All the logic behind these measurements has been already outlined and clarified by Lina and Dimitris, so there's nothing new to say here. Maybe we can just add that for some of these measurements, they may Some of them are not possible, however, for every species, like step density is something that you can do with kelps, for example, or sargassum, like in the picture here. For many fucoids we have in the Mediterranean and Atlantic, that's more difficult because the alphas tend to coalesce, and so also the concept of individual is quite blurred. And along with the subvariables, we have supporting variables to put the EOV into context, into its environmental context, both physical and physical, chemical, and also biological context. And this requires measuring a suite of supporting variables for the environment, notably nutrients, temperature, sea surface and subsurface temperature, salinity, DSC, ocean color. Derived products can help also generating data set, extracting this variable for modeling changes in the EOV at large spatial scale. In terms of the biology in which the EOV is embedded, we have supporting variables that can inform on the health status of the EOV, like photosynthetic activity, photosynthetic biomass, canopy height, plant size, if there is any sign of grazing or overgrazing, but also measurements that help characterizing the surrounding environment, the species abundant composition of the understory assemblages, and also if the EOV is embedded in a mosaic of alternative habitats like burying grounds, algal turf assemblages, which can inform on changes also, on the direction of changes of the EOV, as I will show in a few minutes. In terms of phenomena to observe, here we have basically 4 key phenomena that monitoring the EOV at different spatial and temporal scale, it's possible to identify. The status and trends of macroalgae canopy covering composition in space and time. Of course, this can occur at a range of spatial and temporal scales, horizontal scales, tens of meters to 1,000 kilometers. Vertical range is mostly surface up to 30 meters, more or less, depending on the vertical range of distribution of the species you are targeting. Temporal scales, year or decades. Severe events of population collapse. Well, that is something that may happen over short time scale. So even if the horizontal scale can be, again, hundreds of meters, 100 kilometers, the temporal scales at which this phenomena can emerge, unfortunately, are very short. Some of them show really collapse in a few years. Recovery and resilience, we also have to be optimistic. If we lose this canopy somewhere, maybe we also have the opportunity to observe recovery in other places. And again, the scales involved in this measurement of recovery and resilience in terms of spatial scale are similar to those that are relevant for measuring population collapse. The temporal scales for recovery and resilience might change from years to 10 years, depending on the species. Range shift associated with climate change. Again, here the large scale are important, 100 to 1,000 kilometers. Range shift are observed within years. And the last row you have in this table is the signal to capture, or the effect size that we aim to capture with measuring this EOV. That, of course, will change depending on the sampling design and sampling effort you put forward. But we believe that changes of between 20 and 40% are feasible, effect size that can be reasonably be detected by a low-cost sampling design. And these are effect size that can inform beyond random variability about the key phenomena that the EOV is supposed to capture and is designed to capture. Well, this is when I mentioned the collapse can occur over a very short time scale. This is an example of what we found 2 months ago, basically, during our field work in the Tuscan archipelago. We are in the northwest part of Italy, northwest part of the Mediterranean. We had macroalgal beds here. The canopy is Schistosera, so fucoids, basically. Last year, we had flourishing beds. Now we observe in the middle panel, you see the evaporated bed, and on the right panel, what was last year a 100% cover shelf is now completely, not completely, but almost bare, and now you still see turf getting over. So unfortunately, this without no need to make much measurements actually qualifies the origin shift visually and clearly. And this happens probably, possibly in response to intensifying heat waves. You can get 30 degrees in the water at this depth. We have between 7-8 meter depth, possibly associated with strong winter storms. So this phenomena can be captured, unfortunately, over a short time scale, but you need to have sustained monitoring to be able to identify when they happen and what are the scales in space and time involved. Now I pass the word to Jared, follow on the next step.
Great. Okay. Yeah, we'll keep using the slides you've got. Perfect. An EOV is great. The spec sheet is incredibly useful for providing information for scientists that are working in their programs. But we also wanted to think a lot about implementation. And really, we see the specification sheet and use of the EOV as relevant to two pools of users. And so we've been trying to develop additional tools in order to facilitate its adoption and use so that we can have a very standardized global data set for this essential ocean variable. And so the two types of users that we've identified are new sampling programs. So if you are beginning a new sampling program from scratch, we've been working to try and identify best practices that are needed to efficiently sample the macroalgal EOV, provide standard field data collection forms, and standard data entry forms, right? These are things that a new program needs if they're spinning up from scratch, and we'd like to try and lower the activation energy for that. Second, existing sampling programs. We know, for example, Reef Life Survey or others, there are a lot of wonderful sampling programs that already exist. They've got data collection ongoing, best practices are already established, but the data is not standardized and cross-compatible. As Lena and Lisandro have been talking about, having fair data that is interoperable is absolutely essential to creating an essential ocean variable. Next slide, please. And you can scroll to the end of the animations on this. We would like the data to be unified under the roof of OBIS. If you could click forward twice, please. OBIS is, of course, more than just species occurrences. As Dimitris talked about, this is the world's largest open access repository for standardized marine biodiversity data. And so the challenge placed in front of us is making sure that we can take our data from a wide variety of sampling programs that are created or at least compatible with the essential ocean variable specification sheets and get them into OBIS. Next slide, please. And so what we've begun to do with the macroalgal EOV is develop some standard operating procedures. We're close to getting these up. These will be hosted at Ocean Best Practices. And frankly, for anyone looking for a protocol for a new program, be it macroalgae or otherwise, Ocean Best Practices represents a system that will give you access to a wide variety of well-tested standardized protocols that will ultimately be compatible with any of the essential ocean variables. In addition, for the macroalgal EOV, we're trying to provide tools to start a new program. So if you are one of those users that has a new program, we'll be providing a whole get up and running kit for you to create both tools for use in the field, as well as data infrastructure. And the data infrastructure we're providing isn't just for new programs, but it provides standardized tools for pre-existing programs to easily and seamlessly be able to mesh their data into this larger essential ocean variable program. Next slide, please. Once you have data that is in a format for the EOV, we are hoping to create a long-term data deposition program. In fact, the pieces of it are in place right now. A lot of this has been created by Elizabeth Lawrence and others at OBIS. Some really wonderful tools. I mean, here we have, for example, a map of current sampling programs that have supplied metadata that are part of the macroalgal EOV or will become part of the macroalgal EOV. And really what we're asking of you, our community, is as you create your programs and as you put your data online in whatever repository of choice you so choose, that you then share your metadata with us, share the location of that data, and that way, in the long term, we will be able to seamlessly combine these into a unified macroalgal essential ocean variable for the entire community's use, in addition to your own. Next slide, please. All right. Transitioning back to Lisandro. Oh.
Sorry, this is the next slide.
No worries. No, I can cover this as well. And so, right now, the standard operating procedures that we've created are largely targeted towards visual observing. So this is for field scientists going out, throwing quadrats and taking data, if you will. However, we're developing a wide variety of other tools that are going to be cross-compatible with emerging technologies, automated biodiversity monitoring, eDNA, image analysis, remote sensing, and more. This is where we're going, and all of these different data streams are part of the macroalgal EOV subvariables. They all contribute, and stay tuned for new information and new tools that will allow you to take this kind of data and put it into the macroalgal EOV. Next slide.
Okay, this is the one I just want to make this point. So I mean, designing an integrated network for monitoring biodiversity large scale is a tough endeavor. It has many different elements: capacity building, technologies, how do we measure and what we have to measure, data standards that we have heard. These elements are the core of the discussion we have nowadays. My sense is that we're not discussing anymore, or not enough, about questions and design, whether they are appropriate or not to address the question behind any sampling. So this is a plea for any in following this webinar, or young people, also to spend time thinking how you design your sampling program and which question you are targeting and wishing to address. And go through this very, very, very fast. But the key point is that probably if we will ever be able, and hopefully we are, to have an integrated, coherent network of biodiversity observation globally, this will luckily generate from the integration of existing programs that have been designed to address questions and problems at local regional scales, plus hopefully new ones that will add to the specification we are developing within this panel. And following the EOVs. But if you have existing programs and if you design a program to address local regional scale, you can do it in a way that is also meaningful to address large scale. And here are some hints that can help you to design a meaningful or appropriate sampling program that can achieve many different things, including addressing at the regional or local scale question, also to generate data that can flow into larger data set. This requires having questions. We are not in the space where we can have, for example, using satellite to characterize sea surface temperature. That's not a question. We measure everything is possible to measure. When we go to biodiversity, especially macroalgae canopy cover, we have to deal with discrete sampling. We have finite number of samples to allocate in space and time, and we need to have hypotheses that guide us how we allocate this finite sample in space and time. So examine gradients, environmental gradients, or gradients along anthropogenic pressure, if possible, or make contrast between, for example, MPAs and reference sites, or sites that are disturbed by pressed by human intervention and reference sites. In this way, you generate data, and just going very quick, that address, if you look on the right panel part of this slide, separate that can address local and regional question, but at the same time that can generate data that are meaningful for addressing global trend. If you have an MPA and reference site, you can extract data from the MPA and compare with reference site addressing your local problem but the data from the NPA can be associated with similar data from other regions of the world and combined to accept with data from pristine areas to disentangle global drivers, climate change from local stressor. And that is meaningful for addressing status and trends of biodiversity globally associated with climate change. So think more, spend time thinking while sampling what are the questions and generate a sampling design that can address those questions. That will help you to have meaningful data also to address large-scale questions that can be integrated, standardized, interoperable with other similar data sets to make the global data set for what we are aiming for. Back to you. Jared?
Yes, sorry, answering some questions. Yeah, so in conclusion, really what we are aiming at here is trying to use this macroalgal EOV and the specification sheet to clarify questions and hypotheses and to help enable scientists to decide on how to allocate their samples in space and time in order to get at a useful measurement of macroalgal canopy cover and composition, both for their own use as well as the use in a larger EOV. We really are trying to emphasize using standardized protocols here, either some of those that we suggest or others that are pre-existing, and creating an infrastructure so that a wide variety of different sampling programs can come together and create a whole that is greater than the sum of its parts. At the core of this is the absolute necessity of adopting FAIR principles and moving forward, taking advantages of new technologies so that we'll be able to create a more robust and more informative EOV for the use by the scientific community. Thank you very much.
Well, thank you very much. This was really, really not only very, very nice presentations, is that you were also very, very efficient of answering the questions that people already put on the web for you. So actually, Joanna is asking for the floor. I'm going to ask her to really speak now. Joanna, you want to say something?
I did a mistake.
What? Oh, it was a mistake. Okay. So I think most of the questions were already answered, but I have now two new ones. So Lyle Loka, can you, I mean, this is a very long question, so maybe you can pose this question yourself. Hello? Or Lyle, okay, go ahead.
Okay, can you hear me?
Yes.
I'm an international lawyer and a biologist, and I'm actually new to the EOVs. I've been trying to work with a group of marine scientists in the MENA region, in particular the Arabian/Persian Gulf, over the last couple of years, about more open science in the region and getting scientists to collaborate with each other, and also governments to work with each other in a kind of a scientific diplomacy initiative. And I mean, I'd really like to promote the EOVs in our region. Marine scientists, though, they have a problem because in our region, because of non-disclosure requirements that maybe the sponsoring institutions are putting on marine data collection. There have been calls for regional databases to share data, but I'm thinking that may be too bold a first step, and I'm wondering whether it would make sense maybe to initiate metadata sharing. At least we would know where data is being collected and by whom, to promote the idea that at least we know the work that's being done out there, and perhaps later down the road, sharing could be initiated. I'm wondering what kind of let's say enabling environment is needed, and maybe is being practiced already in North America or in Western Europe, that encourages data sharing.
Well, this is a difficult question. Who wants to start answering? Lina, go on.
I can take a first stab, and then someone can continue. I mean, there are many parts of the world, including Western Europe, where we have this challenge of sharing data. Sometimes due to the military, that we're not allowed, etc. I think what you said, a first very good step is to share the metadata. So we know where things are happening. But also, if you have a national database that is working well, that one can be, as long as you have the right metadata, and that facility can translate this into standardized vocabulary, in our case here, Darwin Core terms. So then that can be connected to any other database, and the data would become globally available and interoperable. I don't know, that might have answered a part of the question. Maybe someone else would like to add on. Oh yes, I could say something about sort of this incentive. Why should we share data? And I mean, the first time you do it, it takes a lot of time to learn this new process. But once you have sort of your field data protocols and everything in order, then it's actually not that difficult. And OBIS are extremely helpful as one of many entry places where you can submit data. They have manuals, and we are working, I know Elizabeth Lawrence that is here, she's working on ways to really facilitate this for people that aren't very good with super complex data sheets, etc., just to make it feasible. And I think everyone that shares data, we need to just celebrate them and tell them that they're amazing. So so yeah.
I don't know if anyone else, Jared or Dimitris or Lisandro.
Yeah, I can throw in really quickly. I just put a link in the chat to the developing EOV metadata sharing site. And again, data not required, right? It's really about understanding when and where data is being collected and what is being collected. And so that is a really easy first place to start. And I think you're exactly right that you need to start somewhere. Once we start getting into the actual data sharing itself, there are a number of incentives. One, there are sort of professional rewards, right, for scientists getting your data cited, getting your work cited. We all know that citation is a currency within our field. But then going forward, the possibilities of what you can do. So if, how do you compare, for example, what is happening within your region to other adjacent regions? So again, I know I keep coming back to the whole is greater than the sum of its parts, but those rewards really do come with that putting together the information. But yeah, one of the, I think, not just struggles, but it's not really a struggle, it's more sort of a mission, I think, in the EOV program, and in working with OBIS, is trying to make these tools as easy and as low friction as possible for people to become part of the larger efforts, and therefore get something much bigger than they can out of their efforts.
If I can add one word about motivation, well, actually the barriers. My feeling, talking also to some colleagues that are not keen to share the data, is that the idea that someone can take your data and tell your story, your local story. And that's not the case. You share the data, and when it's done, people and you as a data provider are involved in a larger scale endeavor and work that doesn't preclude the use of the data to probably address the primary purpose why those data were collected, meaning that you can still do your local scale study or regional with the idea that motivated collecting those data, and on top of that, contributing to larger scale analysis. So one does not preclude the other. And this distinction is not, that my feeling, I may be wrong, but is not enough clear to many people. You're not using the opportunity to use your data to address the question and the local scale region state study that originally motivated the sampling, but you can do more on that. Maybe this does not address the question because some authorities may have other opinion that don't allow you to disclose the data for other reason. But this is more relevant for scientists, individual scientists that are not keen yet, have not matured the idea that they can do more with their own data.
Yes, I would like to hear what Lisandro says about non-opening data, because in the audience we might have people from the industry, and in various regions like the MENA region or other places, Seagrass data and macroalgae data are collected for impact assessment studies. And there they have non-disclosure agreements, not sharing the data, but the metadata that exist under that protocols and that approaches could be quite useful to come out to the audits for the metadata.
Yeah, well, I could maybe also to add that, yeah, I mean, this is motivation needs to be there, but also we need to work on the rewarding system. And one thing that is important is that our data will be also connected with our name, which cannot be done now. And this could also be used to really, for the funders and the people that fund that pay our salaries, really use that as also an important part of our work, because this, I think, will help scientists. For the other barriers for companies and for governments, yes, I think this science diplomacy that was for governments that was mentioned, this is work that could be done also, not necessarily by each scientist, but the scientists can really try to put their more diplomatic also people, because these sometimes there are not very strong reasons to have these blocks. It's just that, you know, it's how it has been done, and really we need to find ways to reduce these blockages in some regions of the world, to really also be able to, for the scientists, be able to really share the data more freely. And also, I mean, and this is something that is still evolving. I mean, some years ago, there was much more resistance to share data. I think we are evolving in the right way, but this is, so what was being said here is there is now a lot of help, also technical help, because this was not easy. So now we have the tools, now we have the help to really, for people are starting to get all these complicated, that are supposed to be simple, but in the end, not so simple, spreadsheets and all that. So there's help for that. So now I think there are much more opportunities, and it's easier to do that than some years ago. And so let's hope that people continue to adhere and to be publishing their data more and more. More questions? Temporal scale data. I don't know why the questions are disappearing because you are answering them, which is great. But there's a question here for Dimitris about the aerial extent. Gilbert and Ron, do you want to ask the question? Could you share specific protocol or monitoring programs, please, for the area extent as a variable is part of the long-term monitoring protocols and the very directive in Europe and other regions? Could you share specific protocol or monitoring programs about the aerial extent?
Yes, shall I answer here? Yes, it is possible to share. I will type my email on the webinar chat and to be in contact. For the Marine Strategy Framework Directive and Water Frame Directive, the member states have to report aerial extent of habitat. So they use various tools, either from hydroacoustics or to satellites, to create such data. And by that, it's not really a specific protocol, but it is standard operating procedures how to map a habitat using side scan or multi-beam or satellites. But of course, I can share you some literature on that.
Well, and for macroalgae, how is this done? Jared or Lisandro, aerial extent. So we have standard protocols for that. Yes. Okay. No examples.
Oh, no, I can definitely throw in examples. I mean, remote sensing is one tool that is starting to advance quite a bit. For example, if you visit kelpwatch.org, let me make sure I have that right. That's a great example of looking at Landsat data to get canopy kelp time series data to look at aerial extent. Here, I'll throw the URL into chat. So remote sensing has advanced as one fantastic tool to look at aerial extent. Others that are rapidly advancing, so tools like side scan sonar, essentially underwater remote sensing, if you will, or mapping, physical mapping in other ways. So there are a wide variety of different tools that are coming online, particularly using more emerging technologies, drones, side scan, autonomous surface vehicles, et cetera, that are mapping aerial extent in macroalgae.
Yeah, because there are those, some are quite deep. I mean, quite deep for satellites to measure. Lisandro, you wanted to?
Yeah, I just want to add that we can really leverage emerging technologies here, because when using drones, or if you have any programs of aerial photographs, then you can use those instruments to train satellite images. So in the end, you increase the ability of satellite images to recognize things underwater if you have high resolution images from drones or other programs locally. So using the AI actually to link and combine these two sources or two types of product to get much higher resolution and low cost.
Okay, we have here another question. We are collecting data, but it doesn't fit EOV SOP. Is possible, can we have opportunities of funds? I don't think it's funds is our business here, but funds for collaborating and collecting EOV data. So Yonki Lee, so for those, I think, Jared, you really talk about ongoing programs. So they already have their standard methodologies and everything. So what can they do if they don't collect the data to fit the EOV specification?
Yeah, that's a great question. I mean, I think it depends. And again, I don't know the specific case. I think there are a number of different ways that you could take the data that you have. And what we're trying to do is create tools that are robust enough that you can give us the metadata about the details of your sampling program. And we'll, be able to process that data and and look at it and say, okay, you may have been collecting for a completely different reason, but you are collecting data that's useful for the EOV. And so I actually think the barrier there is much lower than perhaps it seems at first glance. So that's a piece of it. I think also there are great opportunities to collaborate. Many of the people who are working on these EOVs or in the space are all highly collaborative individuals, even if it's just a simple question of getting data to a place where it can be usable. So I think there actually are a lot of possibilities there. There are also, if you're working with a larger group or have others that are in the same situation, I know there are opportunities and funding workshops for working groups from organizations like SCORE and others that could be ideal for this sort of effort.
Well, thank you. We have here another question, Maricela. I have a question about the temporal scale. A decade is relevant ecologically, but impacts and changes are happening much faster now. Are you considering using 5 years or maybe 4? I think this temporal scale is not all in decades, but I don't know if any of you would like, because it doesn't say if it's for the macroalgae or seagrass. Lina, you want to talk about this?
Yeah, I could say that in the seagrass specification sheet, the ideal time to measure percent cover and species composition is seasonal. And then, of course, not everybody has that opportunity to do it, and then it might be more seldom. I don't know how it is for the macroalgae, and we don't have this also for the aerial extent. There is no time.
Well, for macroalgae, the ideal is to have monthly data. If that can be afforded, the alternative is to sample at seasonal peak of vegetative growth. For the time scale, as we have shown in the specification sheet, can change depending on the phenomena you want to address, and that for long-term changes, years and decades are important. But for short-term collapse, as we have shown, is 1 year, 2 years is what is the temporal resolution that matters. So of course, there is a range of possibility about a range of temporal scale and spatial scale to cover. That is always a balance between resources available and what you think is really important in your system that can happen or might happen and might be worth monitoring. So if you expect sudden collapses because you have seen in the recent year extreme heat waves, for example, or extreme strong storms, then you probably can expect a collapse. Then you should have actually very high temporal resolution of sampling. If things have just business as usual, you won't expect this sudden change or regime shift, and probably you can focus on range shift, especially if you are in a biogeographic barrier, and that requires, or you can have longer temporal scale in your design.
Okay, I think we are getting to the end. Actually, we are 7 minutes after the hour, but this has been, well, this is a possibility of hearing your thoughts about all these questions. So we have you have this the address of the speakers, and you can put more questions. I'm sure they will be happy to. And Jared actually said that they can give you and help with existing programs, really to try to fit into the EOV. I mean, this is very important to implement. I mean, implement is with the people that are on the ground doing the monitoring and the observations. So thank you very much, all of you, for your for being here with us, and especially thank to the speakers that did this great job, and also answering all the questions online while they're speaking almost. And well, I hope you will join us in our next sessions. And well, thank you very much, and goodbye.
And thank you very much to our chair and to the organizers of the webinar.
Thank you.
Thank you very much.
Bye-bye. Cheers.
Ciao.
Very much. It was a
Ciao.
great. Thank you. Thanks. I think it was a very, very, very nice session. With a very
Okay. Yes.